So today I just wanted to talk about something that I thought was going to be really simple, but it ended up being pretty complicated in sharing my story here. So this, what you're looking at, is just a sketch of a pen clip. So this little thing here. I just wanted to mount my Sharpie on the wall, and there came with some objectives. Like for example, I needed this to flex. I needed to have enough frictional forces to, attach the pen so it could stay vertical and not like fall out. But I don't want it to be too tight, so in order to rip out a screw that's not drilled into a stud, right? So something that's floating in drywall that I can easily remove it. And also, nice to have is like a satisfying click. Now, in order to do that, I need achieve these design goals. I needed to, one, to have enough space for the screw head, two, the material to be thin enough on the sides so it can flex a bit. And because plastic doesn't, especially the PLA, it doesn't flex much. So to flex a bit, I needed to think about the diameter. So if I wanted something to grip, if it was the same diameter as the pen itself, then it'll just fall through. Right, so and not exactly because PLA shrinks, so end up being a smaller diameter. Even if you printed it, it'll be a couple percentage points smaller. But in this case, I just made it a millimeter smaller. So this is a diameter of, let's call it 10 millimeters. So I made this as 9. I just eyeballed it, didn't use any sort of engineering or anything behind it. Some cool things, though, that in doing this kind of process and in achieving this goal, I've learned a couple things that would be kind of interesting. So one is the relation, like if you have really stiff materials like plastic or even stiffer materials, you can still make them as flexible or achieve any sort of design goals you want by just elongating this. So if you made this like much longer, 1 degree of movement on the flex point will translate to a much larger range of motion on where you need it to be. So if this was like rubber or something very flexible, I could probably have this to be more like this gap to be a lot tighter to the wall. But I didn't need it to be, but being that, or rather, being that I needed enough space for the screw head to fit, this actually worked. I also came up with another design here, which looks like this. So you get a little bit of a triangle that I thought about. Same kind of concept. It was obviously just trying to put it through its paces, but so it expanded a bit. It's probably something I have to think about in the design process. But here, the reason why I made it this way, so on a triangle, so it's not as aesthetically pleasing as this, but there's a side benefit to this. In the end, it kind of looks like it would have more tension to the pen, but I didn't do it for that reason. I did it so when the pen is mounted on this, if someone wanted to reprint this, they can actually drill these things side by side, and having the pens attached to it wouldn't interfere with the design. That's something that when you're doing any sort of design work, you have to think about. How do people use these things? So it implies that or what people may not realize is that there's some sort of expansion here. So if these were laid side by side together, you wouldn't actually just inputting a pen on one, because this expands like a half a millimeter on each direction. Which will, by consequence of this, it would shrink or make this half a millimeter smaller, which makes it, the grip on per pen or much higher. And also, I'm sure there will be cascading effects and such, where at some point these will be like pretty tight, and moving the pen or locking or unlocking a pen from array of these would disrupt the entire array itself. Well, this design hopefully achieves that. So when the pen enters, it doesn't expand wider than the base of it. But being that I know me and the use case of it, I'm gonna go with what's pretty. And that's my video. Thanks for watching.